Hello viewers, I am Aditya Bhardwaj and today we will see why can't I dig a hole to the other side of Earth. It seems like it should be a simple task. Dig deeply enough straight down and you should strike sunlight on the other side of the planet. But before you break a sweat while breaking the ground, know this. Your hole will lead to a dead end. Why? Behold the whole truth as we examine every obstacle to a shortcut through the soil. Obstacle 1. Earth's crust. High or low, wherever you go on the planet's surface, you are traveling on or above the Earth's crust. Our planet's outer layer began taking shape 4.5 billion years ago, atop the fireball of asteroids, comets, and other space debris that clumped into a gooey lump to form Earth. As the surface cooled and hardened, Earth crust was formed. It comes in two types. When you reach down and feel the ground, you are touching continental crust. It ranges from 6 miles 10 km to up to 47 miles 75 km deep under Mount Everest, the Earth's tallest mountain. Continental crust consists of less dense and much older rocks, and then oceanic crust. Oceanic crust is about 4 miles 7 km thick at the bottom of the deepest ocean trenches. It is still taking shape in the mid-ocean ridges, where molten rock erupts from cracks in the ocean floor and cools to form new crust. Neither crust seems particularly thick, right? Tell that to the geologists and mining companies that try to dig through it. Despite using mid-ocean ridges as a starting point for digging operations, they have been able to pierce the crust. It's too fiercely hot and full of hazards, from pockets of molten rocks to lakes of boiling sulfur. Obstacle 2. Mantle. Even if you manage to dig through the Earth's crust, you will literally only scratch the surface of the planet. Below lies the mantle, a layer of semi-molten metals such as iron, magnesium, and aluminum. The heat and pressure are intense enough to compress carbon into diamonds, the hardest natural materials on Earth. The easiest way to reach the mantle is to ride the oceanic crust. It sinks slowly to the mantle in the process called subduction. Once it reaches the mantle, oceanic crust melts and returns to surface as magma in mid-ocean regions, where it is recycled into a new crust. The whole process takes about 200 million years, so you might want to pack a toothbrush. Obstacle 3. The outer core and inner core. The spherical Mars-sized sea of molten iron, nickel, soars 1,800 miles, 2,900 km beneath your feet. It flows around as inner core of iron 2/3 the size of Moon. This flow of liquid iron around the solid inner core is what creates the Earth's magnetic field. Temperature of the inner core exceeds 10,000 degrees Fahrenheit, 5,600 degrees Celsius, hotter than the surface of the sun. Yet, the intense pressure here locks the molten iron into a solid sphere. Good luck digging that. Obstacle 4. A big squeeze. The deeper you dig into Earth, the deeper your troubles. Gravity pulls trillions of tons of rocks and metals toward the planet's center, and the weight of all rough stuff above your head increases as you dig. The pressure in the inner core is 3.5 million times the air pressure you feel on the planet's surface. Your body would suffer serious damage once you hit 27 times of the surface pressure. Obstacle 5. Tug of war. It's not for the crushing pressure it creates around you. Gravity would be your best buddy during the long haul to the center of Earth. It's all downhill to the Earth's inner core. After all, you would actually experience zero gravity in the exact center of the planet. The vast mass that molten metal and rocks around you pulls in all directions and cancels gravity effect. But you made only into the halfway point. You must repeat all the back-breaking physics-defying work that got you there. Except now, gravity is working against you. It's time to begin the uphill battle to dig you exit tunnel through the opposite half of the planet. That's roughly 3,958 miles, 6,370 km of the molten metal and solid rock you need to dig through. All of it bouncing off your head as you climb up and up towards the